Okay, slopes and equations of lines. Just as a refresher, the rise is the difference in the y values of 2 points on a line, whereas the run is the difference in the x values of 2 points on a line. And so when we talk about slope, we're talking about the ratio of rise to run. So if we've got 2 points on a line, take the difference in the y's over the difference in the x's. So we can also call it rate of change, call it change in y over change in x, all those sorts of things. So again, using the slope formula, we take our y values and we plug them in on the top. We put the x values in on the bottom. Reduce your fractions whenever possible. And I always prefer for slope to be as an improper fraction, because that way it's pretty easy to tell what your rise and what your run are. 2.5 doesn't tell us a whole lot, or tell us as much anyway. So, as a reminder, positive slope, negative slope, zero slope, and undefined slope. It's kind of the general way the shape works. Now the slope of a horizontal line is 0, vertical line is undefined, and then another word that it might be new to y'all is the word reciprocal. Now reciprocal is essentially you take the number and you flip it. So if I've got a over b, the reciprocal is going to be b over a. The idea is that if I multiply the two together, I'm going to get basically ab over ab, which is 1. And also, as you should recall, parallel lines have the same slope, or to have a kind of a specific geometric definition is, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. And so, and kind of as a definition here, any two vertical lines are parallel. So if I've got line S has a slope of 2, line T also has a slope of 2, so they have the same slope, so they are parallel. I know I'm going through this fairly quickly, so I definitely, if this doesn't sound familiar to y'all, I definitely encourage you to go ahead and pause it, study the diagrams here as much as you need to, because I don't want to just rush through it, but again, my hope is that this should be somewhat of a review. Now the perpendicular lines theorem, again, this one might be, you might have a little bit more trouble with this one, but if I've got two lines whose slopes, the product of the slopes is -1, this means they're called negative reciprocals, that means that they're perpendicular. And then also kind of by definition, vertical and horizontal lines are perpendicular. So the two lines that I've got here, the slope of line P is going to be -3, and the slope of line Q is going to be a positive 1/3. Well, if you take -3 and you turn it upside down, you get -3 over 1. Well, -3 over 1 and 1 over 3 are what are called opposite reciprocals or negative reciprocals. So the two lines are perpendicular. Okay, so just a little practice. Given 2 points, want to find the slope. And again, it would probably be a good idea for practice for you to pause the video right here and kind of work on them on your own, and then come back and check your work. So hopefully you will pause it right now. Okay, so on number 1, we're going to take, so here are my y values, so -4 minus a -1 over 8 minus 2, and then we get -3 over 6, which reduces down to -1/2. Number 2, -6 minus 10 over 5 minus a -3 is going to end up being -2. So number 3, we get -10 minus 12 over -10 minus 1, which is -22 over -11, which is a positive 2. And just might mention here that the slopes 3 and the slope for number 3 and slope for number 1, those are perpendicular, if you hadn't quite noticed that yet. And then on number 4, we end up with 28 minus 4, and then 0 minus 22 gets us 24 over negative 22, which reduces down to negative 12 over 11. Okay. Now number 5. This time we're given 4 points, and then we want to know, is line AB parallel or perpendicular to line CD? Well, in order to determine that, we're going to have to figure out what the slopes are. So the slope of AB is going to be 2/3. The slope of CD is going to be negative 3/2. Those are negative reciprocals. And so the lines are perpendicular. Okay, moving along to equations of lines. First thing we have is point-slope form. Point-slope form is if you're given the slope m and a point on the line xy, the equation of the line is y minus y1 equals m times x minus x1. And so, as an example, if I want to write the equation of the line whose slope is 2, which goes to the point 1, 6, I get y minus 6 equals 2 times x minus 1. Now I know it may bother some of you, but this is actually my final answer. Sometimes it bothers me and sometimes I think it's cool. But if you're writing something in point-slope form, this is how you leave it. Because you've got your point, you've got your slope, you're done. You don't have to simplify it any further. Now if someone asks you to, solve for y or put it in standard form, which we'll talk about later, I think, then you have to do stuff to it. But if someone says to write it in point-slope form, you can leave it just like this. Okay, other version is called slope-intercept form. So if you're given the slope and the y-intercept, the equation of the line is y equals mx plus b. So for example, if I've got if m is negative 3 and the y-intercept b is 7, then the equation of the line would be y equals negative 3x plus 7. Okay, horizontal line. Horizontal line is always going to be y equals b. Whatever your slope, whatever your y-intercept is, that's what's going to be your horizontal line. Whether it's y equals 2, y equals 7, y equals negative 4, whatever it is. Now a vertical line, remember for a vertical line our slope is undefined. That basically means we're not going to have a y in our equation. So it's always going to start off with x, so x equals whatever the x-intercept is. Okay, so x equals 2, x equals negative 1, whatever. Alright, so again, there's some practice problems here. I would like to go ahead and also again pause the video here just a minute so you can work the problems out, and then you can come back and check your work. So number 1, these are in point-slope form, so I'm not going to try to simplify them any further. I'm just going to write them just the way they are. So number 1, I get y minus 5 equals negative 2 times x minus 3. Number 2, y minus 2 equals 2/3 times x minus 1. Number 3, I get y minus 4 equals negative 4 times x plus 1, because a minus a negative, we get a plus. And then number 4, we have y plus 3 equals negative 3/4 times x plus 2. Okay. Then for slope-intercept form, y equals 6x plus 2, and y equals negative x minus 4. And then finally, putting them all together, we get writing the equation of a line through 2 points in the slope-intercept form. Now there are 2 methods you can do, and I really don't care which method you use, pick whichever one you like. One method is to write the equation in point-slope form and simplify it so that you basically solve for y so that you end up with y on one side, everything else on the other, and you end up in slope-intercept form. The other method takes advantage of the fact that when you find the slope, you've got the slope and an x and a y, and so you're missing is b, and so you can plug those in, solve for b, and then rewrite the equation. My only problem with that method is that even though the arithmetic is simpler, it sometimes seems harder for students to put it all together. But like I said, I don't care which method you decide to use. Either one's fine with me. Alright, so first off I have to find my slope. So I'm going to take 2 minus 0, 1, so I ended up with a slope of 1. Now the first method, again, I'm going to use point slope form. So y minus y1 equals m times x plus x1. And so I end up with, and this actually works out pretty nicely because I've got my y1 is 0, my slope is 1, so this thing simplifies right off to y equals x plus 1. Doing the second method using the slope-intercept form, I'm going to pick one of my points. I think I'm picking negative 1, 0 in this case. And so I'm going to put that into my y equals mx plus b. So here's my y, here's my m, here's my x. Only thing I don't know is b. So b is going to be 1, so I rewrite the equation, and I get y equals x plus 1. This case, this ended up being more steps, but that was mainly because this thing simplified so quickly. Most of the time, it turns out they basically take the same number of steps. So you don't really, one is not necessarily more, saving more time or more steps than the other one does. Generally speaking, the arithmetic on this one is usually a little bit easier, but it's not by a whole lot. Now when you're talking about pairs of lines, they're going to do one of three things. There's really only one of three things they can do. They can either not intersect at all, and that means they're parallel. And we're talking about coplanar lines here. Obviously, non-coplanar lines is a whole nother story. They can intersect at one point, or they can intersect at all points. Basically, they can lie on top of each other. So the way that you figure out which is which is that you look at the slope and the y-intercept. So if two lines are, oops, sorry about that. If two lines are parallel, then they will have the same slope. So both lines have a slope of 2. So they have the same slope, but they have a different y-intercept. If they're going to intersect, they have different slopes. And the y-intercept we don't really care about. Now coinciding lines, meaning lines that are basically on top of each other, have the same slope and the same y-intercept. And so in order to tell this, you want to put them both in the same form. Usually y equals mx plus b, because that way it's easy to tell slopes and y-intercepts. So if we take this second equation here and convert it from point slope to slope intercept, we end up with the same equation. I will see y'all later.